In chapter 5, we talk about linear relations, and there are different ways to represent a linear relations. One way is by words. So for example,
Please excuse this interruption. Could Ms. Lacasano call or come to the main office? Ms. Lacasano to the main office. Thank you.
okay, so one way to describe a trend is with words. So rectangle 1 has a perimeter of 6. As the rectangle number increased by 1, what happened to the perimeter? The perimeter increased by 2 centimeters. Okay, so on a test or on the assignment, we'll have a couple of assignments for the linear relation unit. So on the assignment, I'm definitely going to be asking you about the trend. So it's always as something increase, what happened to the other variable. Okay, so in this case, like rectangle 1, rectangle 2, rectangle 3, rectangle 4. So as the rectangle number increase, the perimeter of the rectangle increases by 2. Okay, so that's describing the trend. We can also represent it in a table. So you can see rectangle number 1, 2, 3, 4, and the perimeter of the first one is 6, perimeter of the second one is 8, perimeter of the third one is 10, perimeter of the fourth one is 12. And you get those numbers by just counting the sides. Okay. You can also represent it in a graph, which is what we're going to focus on today. Okay, how to create this graph. So in this graph right here, your first column is always on the bottom right here. First column always goes to the bottom. So this is the rectangle numbers. Rectangle number. Okay. And then this side right here is always your y-axis, which is your perimeter. Armin?
I can't find my sheet. Do you understand?
Let me see. Okay, it's your lucky day. Usually I don't give a second package out, but we have a couple of extra for this package. Okay. Again, first column always goes on the bottom. So right here, you have the bottom, your x-axis, that's your rectangle number, and then your perimeter right here. So you can see 1 and 6. So 1, you have 6, so you have the point right there. Rectangle 2 is 2 and 8, so 2 and 8, you have your second point right there. 3 and 10, 4 and 12, like this. Okay. Should I connect the dots with a line? Should I connect these dots with a line? So those who say yes, connect the dots. Those who say no, leave it as dots. Alright, those hurt me, but don't know. Okay, good. Okay, I'm not being ignored. So there's something called discrete and continuous. Okay. So a discrete graph is where you don't draw that line, or you draw a dotted line. Alright? And a continuous means you are considering everything in between dots. So how do you know if you should connect it or not? The easiest way is to think, can you have decimals? So can you have decimal perimeter? Can you have like 1.8 centimeters as your perimeter? Yeah, you can have decimal perimeter, but can you have decimal rectangle number? So can I say rectangle number 1.8? Can I say that? No. Alright, so because you cannot have decimals, then it's a discrete and you just leave it. So it depends if you can have. So this discrete means no decimal. Okay. If you can have decimal values, then your graph is continuous and you would connect it. Okay. And then the last part is what we have been working on, is writing equations. So the equation of this graph right here, if you take a look at our table, what rectangle number does it start with? Look at the table, just the table. What rectangle number do we start with? Yep, 1. But technically, in all tables, you should always start at 0. And especially when we write an equation, we'd have to start at 0. Okay, so to get to 0, just go back 1 row. Okay? EQAO love to ask this. They always get you to work backwards and get to the row 0. So if I work backwards, what would my perimeter be? Okay, here is 6, 8, 10, 12. If I move back 1 row, Kaden? 4. That's it. So at rectangle 0, the perimeter is 4. And so in the equation, that's where you see the 4. That's like your startup fee, what we worked on yesterday. That's your initial value, what we worked on yesterday. So your initial value is 4 right here. Where did the 2 come from? Yep.
How we keep on adding 2 to the perimeter each time we
Perfect.
add 1 to the rectangle number.
Yeah, that 2 is your per. Okay? Adding 2 per rectangle. Adding 2 per rectangle. So that's your per, and that was your startup. Okay, and that's how we come up with the equation. Okay, so as I said, today we're going to focus on this, how to graph this. So here's a little math joke. Okay, what did one year say to the other? And if you want to figure out what they said, there's this secret passage right here. Okay, in the alphabet song, you get the very first song you learned was the alphabet song. What letter comes first, X or Y?
X.
X. That's right. If you need to sing the alphabet song during the test, I don't mind. MNOPQRSTUVWX, and then Y. All right. So no matter how many times I sing it to you guys, one person every year always mix it up. Always mix up the order. All right. So X always comes before Y. This is your x-axis right here. This is your y-axis. Okay? So in an x and y-axis, this side is the negatives, this side is the positives, this side is the negatives, this side is the positive numbers. So when I'm given the point 6,3, I look at my x value, because the first number is x. So where's 6 right here? And 3 on my y. So I look at where 3 is on my y right here. Those who played Battleship before? Yeah. You sucked my battleship at I right here. Okay, so the first letter is I. Okay. What about 1 and 5? So 1 on the x right here. 5 on the y right here. Where do they meet? Alright, at n. So your x value only goes up or down. Your y value is you're going across, left, right. Right? -4 and 6. So -4 on my x, +6 on the y. Where do they meet? At e. Good. Okay, what about -6 and 3? Who has the answer for me? V. Good. -6, 3. So V. Okay. 4 and 0. Good. 4 on the x, 0 on my y, which means it's on the axis. So it's E. -5, 0. Good. -5 on the x and 0 on the y. So it's R. So try to take 2 minutes to figure out the secret message. What did one year say to the other? I never.
I never knew. The next is KNEW.
Okay, let's not spoil it for the others. Let them try it. Okay, take 2 minutes. Try to solve this puzzle. I never knew what. -7, -8. -8. Okay. Try it. Take 2 minutes.
I never knew either. It's not so good at this. It's better than me.
You never got one?
How?
Good.
Where? Well, which one? Copying this whole time.
Which one are you? I'm not copying you. This one. -3, 2. Oh, never mind.
-3, 2. Higher 2.
Maybe the other one.
My
I don't
thing
know.
is puzzles, okay, dude? I think I know my gimmick.
What?
Okay, I never knew what.
I have it. I just don't like. I'm just trying to figure out like what.
Remember, it's a math joke, so it's not the best. Okay.
Oh, yeah.
Gosh.
I never knew we both.
Whoa,
I'm a genius.
oh yeah, we're gonna take it up now. We're on that.
I got it first.
Okay, so
No.
let me go around the world. Right
I
here.
never knew
Shh,
you
bedar, 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 bedar.
are.
Yeah, don't spoil it for the rest.
This
Okay.
is a terrible joke. This is bogus.
I did not write this joke. Okay,
I
for the
know I
record.
blame someone.
Alright, Jelani, what did you get for 02?
W.
Good. Armin, 0 -3?
Which, wait, let me find it.
The right here?
Wait, which
Up
one?
here? 0 -3?
Oh, E.
E, good. Badar, 0 0.
0, 0 is B.
Good. Alright, Nicholas, 8 7? 8 and 7? Oh, good. Kazeh? Negative 6, negative 6?
T.
T, good.
They're not.
Give others a chance. Okay, Shinzei? H, good. Alright, Keijun?
L.
L, good. Maggie? I. Okay, Aisha? 0, negative 7? 0, negative 7? V, good. Yeah, 0 on the X, and then just go down to negative 7. Yiren? Negative 5, negative 4? E. Isabel? Negative 1, 0. D. Good. Max?
K.
3, negative 8?
O.
Oh, right. Okay. Adihi? And? Jenny? T. Franklin? H. Jonathan? E. Hey. Let's see. Alex? Yeah. S. Michelle? A. Yeah. And next one. Yeah. Behind Michelle? No. Yeah. You? Yeah. M. Right. Abram. 2, 1.
E.
Uh-huh. Leandro? 1, negative 6? So 1 on the X, negative 6 on the Y. So 1, negative 6 right here. Where do they meet? B. That's right. All right, and Lucas? Four and 6. 4 on the X, 6 on the Y. L. All right, what's the last word? I never. So what did what did your left ear say to your right ear? I never, because they never see each other. Ha 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 ha. Right? Because your left ear will never meet your right ear.
I never knew.
So they never knew they lived on the same block. Yeah, okay, math jokes.
How does that make any sense?
It's a math joke. The most important thing is
A math joke or a dad joke?
you. The most important thing is you got the math. Now, there. Okay, so you know how to read the points. So now let's see if you can plot the points. Okay. So, given this table right here, number of hours studied and grades, let's figure out how to graph it first. So, what's your minimum and maximum x value? So your first column is always your x, second column is always your y. So what's your minimum? What's your maximum here? Adihi? 0 to 10. So what do you think is a good scale for me to go up by? Between 0 to 10, Jenny? Go up by 2s or 1. Yeah, 10 numbers is not that many, so going up by 1 sounds reasonable. Right? Maximum, minimum, y value? Yeah. 20 to 100. So I can't go up by 1s because I don't have 100 squares here. So what's a good scale to go up by then? Yep. 10. Yeah, you can go up by 10s. Okay. Independent variable, it means your x. So in this case, it's the number of hours studying. And then your dependent variable, you will be asked this on the test, independent and dependent variable. Your dependent is the y, and it's going to be great. Okay. So what's a good title for this graph that we're going to make?
Good job.
What do you think is a good title? What are we trying to compare? Adihi?
The influence of the number of hours studied on grades.
Okay, the influence of this on this. All right. So in science, I know you guys always have to do graphs, and this title will always work. Your y versus your x. So in this case, number of hours studying versus grade. Oh, sorry. Did I? Oops, my bad. Y versus x. Yeah. Grades. Grades versus grades versus
Versus hours of study.
hours of study. Okay. Make sure you don't mix it up. If you write x versus y, it's not a proper title. So it's not the most creative, but it will always work. Okay. So if you want to be creative, sure, but just make sure it relates both. Okay. Your x and y axis. Okay. How do we calculate average? Okay, I'm given this table of marks right here. Jenny?
Add all the grades up and then divide it by a number of,
Good.
yeah.
Okay, so add up all your y values, not x value. Add up all your y values. And then divide it by the number of data points. So in this case, there's 6 of them. And so when you add it and divide, you should get 70. That's the average grade. Okay. So now we can graph it now. We have all these data. We have a scale. Should I be doing a L graph or a T graph? Okay, who says L graph? A graph that looks like this. Who says a T graph that looks like this? Okay, so those who say L graph, why L graph?
Because there's like no negative and it's all positive, and
Yeah.
the T graph is for when there's like negative.
That's right. So in this case, L graph because there's no negatives.
That was good.
So right here, I have my x-axis, I have my y-axis. So my x-axis, y-axis, this is number of hours studying. And this side would be my grades. Okay. For our x, we said we're gonna go up by 1 up to 10. So this number right here, this corner, what is that corner? What number is that corner? 0. On both sides? Yes, on both sides. It's always 0, always 0. Even though my first number is 20, I cannot start off with 20. That corner is 1,000% 0. Okay? So it can only be 0. So now we're going to go up by ones, we said. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And then for this, we said we're going to go up by tens. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay. So now we plot the points. 0 and 20. So 0 on my x, 20 on my y, and I'm going to put a point right there. Okay. 2 and 60. So 2 on my x, 60 on my y. So where do they meet? I put a point. 4 and 70. So 4 on my x, 70 on my y. Go up, go across. So right there. Okay, 6 and 80. So 6 and then 80. 8 and 90. And then lastly, 10 and 100. Okay. So now back to my question is, should I connect the dots as a continuous graph, or should I leave it as dots and make it a discrete graph? Okay, so who say discrete, don't draw the line? Who says continuous, draw that line? Good. Okay, so I can draw it. So when I draw this, I'm gonna draw a line that goes like this. Okay, it goes through most of my points. But what about this one down here? What happened to this? There's a name. It's too far away. It's like not related to all the other points. There's a name for this point. Who knows the name for this? You guys learned it in science. I heard it. Yeah? I heard it. I heard someone say it. Starts with an O. Yeah. Outlier. Alright, and it's outlier, L-I-E-R, not L-I-A-R. It didn't lie to you. Alright, that's called an outlier point, which means it's like a wrong data or something. Okay? That doesn't go with the rest of the points. Okay, so if you take a look at this graph right here, even if you don't study and just pay attention in class, what mark should you get?
100.
Based on this trend. Based on this trend, if you don't study at home but you only pay attention in class, you should still be able to get 50. Alright. So this 20 right here means you're not doing homework at home and you're playing on your phone in class. Okay? You see where I'm going with this.
But he still gets good grades somehow.
He's an outlier. Okay?
Yeah, it would be.
So, on the test. On the test, if I produce this graph, will I get full marks?
No.
Why not?
Title.
Good job. Title. You don't know how many marks I've taken off for titles. Alright? So, grades versus hours studying.
It's gonna go to the BSA party for Halloween. BSA party for Halloween.
We'll talk about that after.
Who's bad? You look like a Democrat.
Okay?
Shut up, bitch.
Boys. Okay, second graph, same idea. This first column is my x, this second column is my y. So what's my minimum to maximum value? Jelani? Sorry? 1 to 6. So what's a good scale to go up by? What's a good scale to go up by then? 1, yeah. Okay, what about my y? 4,200. So what's a good scale to go up by? Okay, Abraham. I need to fit 4 to 200 in this small graph right here. So what's a good scale to go up by? 20. Sounds good to me. Alright, you can do 15, but 15, you're easy to make a mistake with your scale. Alright, independent variable, number of days. And then dependent, number of bacteria. Alright, so what's a good title?
Bacteria versus number of days.
Sorry, Bidar?
Number of days versus bacteria.
Y versus X.
Because
Y versus X.
versus Y. Bacteria versus X versus Y. X versus Y. I said it.
No, Y versus X. Don't mess him up. So, bacteria versus number of days. If you want to be a little creative, bacteria growth versus number of days. Alright, sounds so much more creative already. Alright, but remember it's Y versus X.
Somebody evict this guy from the class.
You can't do that. I don't believe
All
you.
your voices.
Alright, so L graph or T graph?
If the president was here right now, would you act like this?
Oh.
L graph because there's no negatives.
Define me. Why the hell would I do it?
Okay. So we said to go from 1 to 6 right here. If I just do 1, 2, 3, 4, 5, 6, my graph is going to be so tiny. I gave you this big space right here. So what I could do is I could skip every 3 blocks. Alright, 1, 2, 3, 4, 5, 6, like this. Okay. Two common mistake that I always see people do. They go 0 and then they put 1 here and then they decided to skip every 3. Alright. If you are skipping boxes, you have to skip for every number. So between 0 and 1, between 1 and 2, between 2 and 3, you are skipping the same number of boxes. Okay? Otherwise, you're gonna get a screwed up graph. Okay? Second thing, notice where I'm writing the number. I'm writing the number on the line. Okay? So I'm doing the ticks. You're not doing a bar chart anymore, so you don't write the number inside the box. Okay? So that's like grade 6 where you do bar graphs. So now we only do line graphs. So on the line. Okay? We want to go from 4 to 200, so we said we're gonna skip every we're gonna do 20s. So I think we have enough to do 20, 40, 60, 80, 100, 2, 4, 6, 8, 10, 200. 2. Okay, so we're going every 2 with the 20. Okay. So now that you have a nice scale, notice how I'm using up the whole graph. If I just counted squares, my graph will be this tiny, and you'll lose marks. Okay. So 1 and 4. 1, 4, about right here. 2 and 16, right here. 3 and 40, right here. 4 and 80, right here. 5 and 100, 5, 100. And then last one, 6 and 200. Okay, it looks something like this. So, is this a discrete or continuous graph? Who says discrete? Leave the dots and don't connect them. Alright, who says continuous? Something happens in between the dots. I should connect them. Okay. Again, think about if I can have decimals. In between days, there are hours, there are minutes. you can have decimals because the time doesn't jump. Okay, time is always continuous. So time is always continuous, so I should be connecting these. So, should I be drawing like 6 lines then? Should I go connect, 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 connect like that?
What's
I-
the most common
This was you guys. I'm using a pencil, by the way. I'm using a pencil. Don't draw it. This was grade 1 when you guys connected the dots and got a picture of an apple, a pointy apple. Okay, this was grade 1. All right. In grade 9, we don't do this anymore. That's why I use a pencil. We don't connect the dots anymore using 10,000 lines. We only draw one. All right. Should I draw a line to connect all these? Can I draw a line to connect all these? Or draw a line that makes sense? All right. Other than a line, what else can I draw? I heard it. Curve.
Line.
That's right, curve. So I can actually draw one nice smooth curve. Alright, and I only drew one. Alright, so one line or one curve. Okay. If you look at the question itself, I actually told you guys right here. A linear graph will mean you get a line. A nonlinear graph will mean you get a curve. Okay. So if you read the question carefully, I gave you guys a hint. Okay, and the reason why I drew a curve right here is because the points line up to form a curve. Wow, good job. Yeah, this is called a line of best fit. What would this be called? What is this called then? If that's a line of best fit, this is a curve of best fit. There's such a thing. Okay. Will I get full marks for this graph?
No.
What am I missing?
Title.
How many marks am I losing on the title?
all?
Yeah, oh, you're right. Here, here, and here. 1.5 marks, just like that. What a bummer. You did all that work and you lose 1.5 marks on the easiest step. Alright, so make sure. Label your titles. 1.5 marks. That's a lot. Okay, last type. Minimum, maximum, x value? Minimum, maximum?
Cross graph.
Alright, but what's my minimum x value? -10, and I need it up to +10. What's a good scale to go up by? I need to fit -10 to 10 in here, so what can I go by? Okay, I could go up by 1 or I can go up by 2. In this case, it doesn't really matter. 1 or 2 is good. Okay, what about y value? What's my minimum? What's my maximum? Armin?
-10
Yep,
and 35.
good. So what's a good scale to go by? 5, yeah. 5 sounds good. L graph or T graph? Why?
You need negative.
Negatives, that's right. Okay, so I have this. Now instead of drawing my T right in the middle, I'm gonna drop it lower a bit. Why? Jenny?
On the top there's more.
Yeah, I need to go up to I need to go up to +35 for my y. So that's why I'm cheating a little and I'm moving my x-axis down so that I have more room for the y. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, perfect. So this is +10 and this is -10. For my y, I said I'm going by 5s. So I think I can do every 2 boxes. So negative 5, negative 10. So 5, 10, 15, 20, 25, 30, 35. Okay? And remember, if I'm skipping every 2 for the positive side, I also have to do the same thing on the negative side because it's the same axis. Alright. Looks good. I'm using the whole graph. Negative 10, 35. Negative 10, 35. Right here. Negative 6, negative 10. Negative 6, 1, 2, 3, 4, 5, 6. Negative 10. So down here. 0, 3. Right here. 2 and 15. 4 and negative 5. 8 and negative 2. And then 10 and 10. Here. Okay. So you see how important it is to do a scale? Because now my graph is perfectly fit in my grid. It's not too big, not too small. Okay. So should I do this now? Should I draw the 1, 2, 3, 4, 5, 6 line? Should I draw this and make a W? Ooh, I made a W. Should I connect all the dots like that? Who says yes? It looks beautiful. Who says no? It looks ugly. Yes. Good. So that's what I'm going to write on your test if you do that then. So I better not see you do that. Otherwise I am going to write on your test, it's hideous. Okay. Discrete or continuous? Discrete. Alright. Why am I not connecting them?
It looks ugly.
Okay.
You said.
Okay. A mathematical reason? Yeah? It's a scatter plot, which means there's no relation between your x and y. Alright. Will I get full marks for this graph?
Yes. No. The title.
Oh, the title. But what title?
No title. X
X.
and Y.
X-axis and y-axis. That's right. Okay, I still need to see that. X and y-axis. You can't have a title because there's actually no relation between x and y.
No, but what if you put the title outside?
So here you won't write y versus x because there's no title. Yeah. So in a scatter plot, it means there's no relation between your x and y value. So that's why you cannot make any connection. You cannot connect them. Okay, so that's the lesson. As I said, today's lesson was longer than the usual ones, but now you guys know how to graph. It's a important introduction. All right. Your homework tonight is actually example 1, 2, and 3. All right. So try these 3. Your homework tonight, example 1, 2, and 3.